Hello, welcome to the Wave Nature of Light, video number 5, polarization. Now, we've learnt that light is an electromagnetic wave made up of a self-propagating magnetic and electric field, and that it's part of the electromagnetic spectrum. Now, with the polarization, what we can do is we like to envisage that one photon of light is vibrating in all possible directions, or that light coming, if we take a bundle of light, so lots and lots of light shining onto a surface, for example, all those electric waves, electric fields and magnetic fields are vibrating in all possible rotations around that path of propagation. And so when we polarize it, what we are said to do is to block all but one of those possible vibrations, or orientations is probably a better word for it, and then it's said to be plain polarized. Bit hard to put it in words, so let's have a look at what we mean by in terms of a diagram. Here we have, if this is light or multiple light sources, well, even though it's shown as a single line, it's representing lots of light. The light can be vibrating perpendicular to its path in any of these 360 full circle variations, okay? And they're trying to show that here as well. So you have in this case they've simplified it down into two possible vibrations, one that's that way and one's this way. Now when we polarize light, what we're doing is we're blocking out all these possible variations and only letting one be apparent. Now that can happen naturally, or it can happen synthetically. We can make it happen. And so what's happening is, for example, if this is the polarizing material, it only allows one vibration to pass through. And so the light that you see on this side of the polarizing material is plain polarized. And here they're trying to show it again, in that you get polarized light coming through in that direction there, from all the possible variations. And here they're showing it again. Here they've got two polarizing filters, and effectively polarizing filters will only allow light to go through them if they have one orientation of vibration. Or propagation is probably a better word. Again, gets a bit technical in terms of the wording. And so here they're trying to show a red wave and a blue wave of light. And in this polarizing filter, which is orientated this way, only the blue light can go through. Now if the blue light, which is plain polarized, then hits a second polarizing filter, it can only pass through if the polarizing filter is orientated like this. And so in this case it's actually blocked. And when we get some polarizing filters in class, you can see that with two polarizing filters you can block all the light that is transmitted. Now, so some examples of that is obviously polarizing sunglasses. People use them for fishing and when they're doing water sports, because most light that bounces off a flat surface is polarized. So light that bounces off the water is actually polarized to that plane. And so if you're out fishing, you get a lot of light bouncing off the surface of the water, and by wearing polarizing glasses you cut out a lot of that glare and you can see fish underneath the water. People use them for other things as well. The readout on your calculator relies on polarizing light for you to actually see the numbers and things, because only the light in the crystals inside here are turned on and off to only allow light of certain vibrations through, and that's when you see the actual numbers. And there's a whole lot of other uses of polarizing materials. People use them in microscopes. Geologists rely on them for polarizing microscopes, and other things as well. Now there is, on the OneNote, there's a movie demonstrating polarizers with the TV and various other things that are shown. So that will be on your OneNote. Hopefully by now I've already demonstrated Young's double slit experiment and I've brought out the polarizers, but if I haven't, give me a hoy and I'll bring them out for you to have a look at how they work. And we are also now able to do a few questions in our workbook. So that should pretty much leave us, and next one we'll do refraction. See ya!